Alright, I'm going to give you some guidance here on how to make the velocity versus time graph for your Lab 4. And Lab 4 is about constant velocity. So your graph, when you construct it, should have approximately the same velocity across the graph. Okay, but we need to know what the velocity is at specific points in time. The instantaneous velocity at specific points. For example, what is the velocity at time 1? What is the velocity at time 2? Or what is the velocity at time 3? And so on. Well, to do this, we have to make use of the fact that we're going to use the average velocity during the previous time interval, the time interval before t1, the time interval before t2, and the time interval before t3. So to find average velocity, we know that it's displacement over time, and that's the mechanics equation number 1 on your reference tables. So let's look at what your displacement versus time graph should look like. It should look something like this. So let's say we want to find the instantaneous velocity at time 2. Okay? Well, we're going to find the average velocity between time 1 and time 2, because that's the previous time interval before time 2. That means we need to find the average velocity. To find the average velocity, we need to know what the difference in distance is, or displacement that is, and that's simply d2 minus d1. And the other part is the time, which would be time 2 minus time 1. And what is this average velocity? Well, we're assuming that it's the velocity at time 2. So it's v2. And you should recognize this equation that we just did. It's simply the slope equation. And we know that the slope on a displacement versus time graph is velocity. Okay? So now you have enough information to graph your velocity at time 2, what is v2. And this leads us to what is likely to be the calculated values that you're going to make a table of. The velocity are the calculated values. Of course, you already have the time, but to make it neat, you can put them into this table as well. Hope this helps.